Hello, hello, hello. What ho! Welcome back to another exciting adventure of The Plain Truth. I'm your host, Travis Finley. I just came across an article that I have not read yet, but I thought I would start reading through it with you and just see where it takes us. I was looking for a link for another article and came across this one on visible and invisible mirages, comparing inferior mirages and the visible and thermal infrared. That should be interesting, so we'll see where this goes. Just as soon as... There we go. All right. Mirages are among the most documented atmospheric optical phenomena since they are rather frequent and are easy to observe and record. Mirages are formed when the light rays bend as they propagate through regions where the atmospheric refractive index varies significantly from its usual state, causing an observer to see additional images of an object located above or below its usual apparent location. So just to stop right there and focus on something that you need to pay attention to for this qualification. Below its usual apparent location. That means you have to have a control image, okay? That means you have to have something that is the standard, usual, the standard, that which is usual, okay? And the other thing that I want to point out is that it allows for superior above or inferior below. And if you know my position, I am of the position that there is no such thing as a superior mirage the way they have been described to us, and that there is simply mirage, which means that you have a target and then you have an image below the target. There's no need to differentiate between inferior or superior. There's just a mirage, and the target is always above the inverted image. So here comes the science, the modern accepted popular science. A superior or higher mirage appears above the erect image of the object, whereas an inferior or lower mirage appears below the erect image of that object. Either type requires strong deviation from the normal atmospheric temperature profile, which cools with increasing altitude at a rate of approximately 7 degrees per Celsius, 7 degrees Celsius per kilometer. I think it's more like 6.5, but the thing that I want to comment on right here is that we have this statement of both. Either type requires deviation from normal, which cools. Either type requires. So they both require cooling, increase in cooling temperatures as altitude increases. So how do you differentiate between what creates a superior and inferior mirage? Okay. Now, the other thing that I find interesting, and to a certain extent think that this needs to be clarified and perhaps cited, and that is this, that we are told that heat is less dense than cold, which means that the more dense the cool air is than the hot air, dense being more dense would mean that it would be lower in the altitude, in the air, than the hot air. The hot air is lighter, the hot air is less dense, so it's going to go to the top. But that's not what we have out in the distance, because the surface of the Earth, right, the surface of the Earth that is hit and warmed by the sun is the hottest. And as soon as you leave that surface, it cools off and cools off and cools off. So you have an imbalance of density layers, so to speak, of a gradient. You have the denser layers on top. That doesn't make sense. Unless I'm missing something, somebody point that out, okay? Because of its higher number density, cold air has a higher refractive index than warm air. Therefore, warm air overlying cool air, that shouldn't happen, because the typical way of looking at it is just what I explained. So to have cool air below warm air would be the anomaly, I think. Therefore, warm air overlying cool air can cause light rays originally directed up downward, creating the object floating in the air above its usual location and flipped vertically. This superior mirage situation occurs often over the ocean, resulting in upside-down images of distant boats or islands that appear to be in the sky just above the horizon. The same situation also occurs with strong temperature inversion in polar regions, giving rise to images of upside-down and distorted mountains that appear to float in the air. If the situation is reversed so that a layer of very warm air lies below cooler air above, light rays from the sky above the horizon can be refracted upward to cause an observer to see a region of sky superimposed over the underlying surface. That I've done this for 6 years and I have no idea what this is saying. This doesn't make any immediate and innate sense. If the situation is reversed so that a layer of very warm air, what does very warm mean? What does that mean? How much warmer is very warm? Light rays from the sky above the horizon, that's just a phenomenological faux pas. It's a mistake to speak that way, because that's not how we see. We don't see vertically. We don't see with altitude out there. We see across the distance. So that when we see the horizon, we're not seeing then up. We're still looking out over the distance. Okay. Light rays can be refracted upward to cause an observer to see a region of sky superimposed over the underlying surface. Is that a complicated way of saying that the sky can be miraged? Okay, I agree with that, but I don't know if that's what that actually means. This is the common inferior mirage effect in which occupants of a car can see what appears. Now, why are you switching to terrestrial observations when you were talking about looking over the ocean or looking over water, right? This is not going to be helpful. This is the common inferior mirage effect in which occupants of a car can see what happens or what appears to be a lake or a puddle of water lying on the road ahead of them. For this to occur, the atmospheric temperature gradient must change with height. That's a given. That goes without saying. It's meaningless. All mirages generally produce distorted images that change over time because of turbulence or even atmospheric waves. That's an interesting term to look up. And that's not necessarily true. The changing over time because of turbulence is more akin to the Fata Morgana, which again is just a mirage in a dynamic, turbulent, energetic phenomenon. The science of visible mirages has been used to resolve mysteries involving missing islands or unidentified optical phenomena and to explain historical mirage observations. The same scientific principles have been applied to inverse problems to recover atmospheric temperature profiles from mirage images. The same scientific principles as what? Have been applied to inverse problems. What does that mean? Like, what does this mean? The fascination for mirages and other atmospheric optics phenomena, that's a bunch of, stems primarily from their easy observability with the naked eye. However, Investigation of such phenomena are adjacent spectral regions using suitable detectors. However, investigation of such phenomena in adjacent spectral regions using suitable detectors can prove similarly fascinating for experimental physics. For example, in the 70s, when was this paper written? 2014. You can't get anything more recent than the 70s. Cameras with film sensitive to near infrared light were used to record the first observed infrared rainbows in the wavelength range of 800 to 900 nanometers, maybe. And modern digital single length.